Hi guys, this is a demonstration of how to set up the Arduino again with the code supplied at the blog post. The main purpose of this is just to plot out some of the voltages that we can plot it on the serial plotter, and then also use the serial monitor to plot out the values and take those into Excel. So I'll step through that briefly. I'm just going to open up the Arduino IDE. And we'll also do a process of copying over the code. So you'll be starting with a blank program, like so. And what you'll also find in your lab sheet when you open it is a link that brings you to the code as well, just like before. And you'll need a password. It's LM358. And this is the code you need to copy over. So it's very similar to the last one, but just change it slightly. But copy all of that into a blank Arduino workspace. So save it as whatever you need to save it as. So my one here, I'm saving it as ESCO or App4, something like that, so you'll remember the name of it. And when your Arduino is connected, remember, before trying to upload, make sure your board is set to Nano processors 18 mega 328p old bootloader. Your port is set. That'll be different for different computers. And then that the programmer is AV or ISP Mark II. When that's the case, you can upload it. And what you're hoping to see down the bottom left then is done uploading. Now, at this stage, we can run the different tools for viewing what's happening on the oscillator. Now, the second you have the oscillator powered up, it is already producing the output waveform. We don't have to tell it to start this time. But what we do have to do is when we open up the serial plotter, is to tell the plotter to start recording. And we do this the same way as before by typing in a character and hitting send. So make sure your baud rate is set to 115200. Character I'm using is C to make them comma separated values. That'll be important in a minute. When we hit enter, the Arduino program will record what's happening out of the oscillator and then print it onto the screen for us. So what you're actually seeing here is the square one here is the output of the op amp. And that's the square wave oscillator. Whereas the red is the voltage across the capacitor in that circuit. And this is what's being used to actually control when the output shifts from high to low. And we can control the time of that by changing the value of that R or that C in that RC series circuit. We'll leave it fixed for the moment. So that's one of your submission items, is a screenshot of that. Now if I close off that serial plotter and open up the serial monitor, this is essentially doing the same job as serial plotter, but instead of plotting the information, what it'll do is it'll give us the actual data points. So again, type C and hit enter, and you'll get all these 3 columns of data back. So we're going to take these into Excel. So the first thing to do here is select that, Control A, and copy to your clipboard, and we'll open up an instance of Excel as well, and a blank workbook. Now in the form, it helps to do is at the start, but in the form that your data comes back different, that serial monitor is, the first column is time in seconds. The second column, if you're wired up correctly, will be the voltage at the inverting input, so a little negative there, that's measured in volts. And then the third column will be the V out, that's measured in volts. So you're just setting up your columns beforehand. Now select the cell here and you can paste in the values, and people remember this from the last lab, but you'll see that they're trying to fit all the values into one column. But we need to tell Excel that these are comma separated values. So to do that, after we paste, we go to data, across from to text of the columns. We want to have delimited set and hit next, and select comma as an option to delimit them, and then hit finish. You'll see a little preview here that's telling you that they're going to be separated into their own columns. So now we have our data separated. So to produce a scatter plot with that data on it, what I'm going to do is I'm going to hold down on A and drag across. So I highlight all three columns, and I'm going to go to Insert, Scatter, and I'm going to use a scatter with straight lines. And you produce this, and you'll see it's the same data as was in the serial plotter. We just were able to use it in Excel here. So I'm just going to leave that to the side and come back to the lab sheet for a moment. Now you'll see one of the deliverables in the lab sheet. One of them is obviously the screenshot of the serial plotter. The other then is the plot that you produce in your Excel program. And that will be this plot here. But before you submit that, make sure you give the axes the right names and right names and units. Otherwise, this plot won't make sense on its own, and give it a proper title. Now, some of the calculations you're expected to do for this are around calculating what the frequency should be for this circuit, or the output waveform. And you do that using these three equations. And then finally, you're going to estimate it using Excel. So I'm going to leave that to yourself to work out how to do that. But remember that the period of a waveform is the time it takes to complete one whole cycle. So you can do something like this yourself in Excel if you want. You know, the values you need to produce here, first of all, you need to know what the time constant of our circuit is. That'll allow you to get the period. And if we can get that, we can get the frequency. And we can put these in as equations into Excel. So our time constant, well, that depends on the value of our resistor and capacitor. So for this, let's say, for example, our resistance was actually 140,000. No, let's make that a bit smaller. Let's say it was actually 500 ohms, just as an example. And the capacitance was 0.01 microfarads. So in Excel, that's how you do it. To enter values, hit equal and then the number afterwards. Well, you know from your equations, as in equation 2, our time constant is the product of those two numbers. So we'll say this one is equal to or multiplied, that's shift 8 on keyboards to get that star, multiplied by C. So that's the time constant for this circuit. So this is in ohms, this is in farads, and this is in seconds. Now our period, I gave you the equation for the period of this circuit. It's 0.96 multiplied by the time constant. And that is also in seconds. And our frequency, that we can see here in equation 3, is 1 over the period. So that's equal to 1 over period value. that's in hertz. So if the values of our circuit were these, that's how we would calculate the frequency of the oscillations. But they're not. The values you actually have are 100,000 ohms, and if I double check that myself, is 1 microfarad I have in? Yes, 1 microfarad. So that's the approach for working that out. If there's any other questions, you can get in touch with me.